Okay, I think this is live now. So I am going to post the link in Schoology. Having a hard time getting there right now. It's not showing up. Oh, good. So to let everyone know that that we are on live. And then I hope that you guys had brought some questions. I'll take a look at the Q&A app and we'll go through them. If not, we will just go through the ones that I've posted and we'll look at things that are like the essential skills, limiting reactants, and the lab. And I think that'll be pretty good. I think it might help some people. And of course, you can always come in early before school. I'll be happy to help you go through some of the problems, maybe from the study guide or the limiting reactants worksheet. Or I also have other worksheets that I'm going to I'm going to show you some of those. So if you needed more practice or you want to take a look at them, we can do that. So I'm posting in Schoology. Hangout happening now. Is it everywhere? All the classes. And of course, some of you might be watching the recorded version of this, which is just fine. All right. Next slide. Okay. And let's take a look at the Q&A app and see if you guys have posted any questions. And the only questions posted so far would be my questions. That's fine. So what I thought I would do is maybe I'll go through, I'm going to go through each essential skill first, and then I'll do a problem. And I have a worksheet that is, where is it? There it is. I have a worksheet that has different variations on this, and I'll find the ones that will fit our situation the best. It's a very different style, but it would be just fine. So we can do that. Okay. So I'm going to go ahead and get started then. Essential skill numero uno. The question is grams to moles or moles to grams. So what I'm going to do is I'm going to show you this question first, and then I'm going to go to the blue paper and work out the problem. So in a grams to moles or moles to grams, it is, like we said in the warm-up, it's the same substance. And there are some balanced equations. We'll come back to that. Let's see. I tell you what, we'll take a problem and kind of work through the different parts of it. Let's do oh, I thought I just had one. Okay, here we go. Number 12. When 9.34 grams of zinc react with excess hydrochloric acid, how many grams of zinc chloride will be produced? Well, let's just do, if we have 9.34 grams of zinc, how many moles of zinc is that? So let's just do that really quick. And I'll just put it up here. So essential skill number 1. And if you've watched this, I prefer blue ink. So grams to moles and moles to grams. It's the same substance. So let's see. I said 9.34 grams of zinc. So if we have 9.34 grams of zinc, we have to convert it to moles of zinc. And this should be old hat to you guys by now. Okay. And if we do that, you're going to be making a bridge. And the generic bridge, if you guys remember, your given always goes here. Okay. And then what you want goes up top here. And what you want to cancel goes down here. Pretty standard. That's going to be the same style or same template you'd use for all your bridges. So in this particular situation, we have 9.34 grams of zinc, number, unit, substance. And the things we want to cancel, right? So this grams of zinc has to be down here, grams of zinc. And what we want, well, we want moles of zinc. So moles of zinc up top, okay? And you'll remember that whenever we have we're converting grams and moles, and we have a conversion factor where moles are involved, and it's not the mole ratio. The number you're gonna give moles is 1, okay? And then the zinc below is the molar mass, and I have a periodic table here. It's not our standard periodic table. I forgot that at school. So I have 65.39. I don't know if that's the one we use, but that's gonna work for now. And so then all you have to do is divide what the mathematical relationship this should be is that you should have a 9 times 1 divided by 65.39. I mean, if you're gonna plug it in, right? That's the mathematical order of the operations. So really, I mean, 9 divided by 65.39. Great. And so my answer is 3 sig figs, 0.1376 moles of zinc. And I just said 3 sig figs because it's 1, 2, 3 sig figs up here. So 1, 2, 3 sig figs has to end here. This 6 is going to make that 7 round up. So our answer is 0.138 moles of zinc. Okay. And you know, if we had gone the other way and said, oh, we want to convert 1.50 moles of zinc to grams of zinc, same thing with the table, right? Given, cancel what we want. So we're going to do 1.50 moles of zinc, and this same thing has to be down here. So moles of zinc are on the bottom. And what we want are grams of zinc. And it's just the flip-flop of the one above. 1 mole and 65.39 grams on top. And 65.39 times 1.5. That's going to end up giving us 98. We had 3 sig figs, 98.085 versus 98.1 grams of zinc. Number, unit, substance. Okay? All right, that was essential skill number 1. Any questions? Well, I say that. Any questions? There weren't any. So we're done with essential skill number 1. So let's do essential skill number 2. And remember, if you guys watching, if you guys have any questions you want us to go through, post them up there in the Q&A app. All right, essential skill number 2. We selected converting moles of A to moles of B. And let's go ahead and, oops. Oh no, that's right. I messed up my questions. You guys don't, I'm sorry, you probably didn't even see that. So I am going to go back to that paper. And so this is essential skill number 2. An example of essential skill number 2 would be, wait, I just had one. Oh, this one right here, number 9. Copper metal reacts with silver nitrate to form silver and copper 2 nitrate. How many moles of silver will be produced from 3.65 moles of silver nitrate? So you have moles of silver nitrate, and you want to know how many moles of silver you're going to produce. So let's go ahead and, oh, I did it again. Let's go ahead and share that. Okay. All right. And to do this, you need a balanced equation. Well, we'll be kind enough to provide you that kind of stuff. So if we had copper, so this is essential skill number 2, and it's the mole to mole. It's sticking. Mole to mole ratio. Okay. All right. Let's do a different color now. All right. The template would be, hey, it's just again, it's a 2-step bridge. It's always your given. What you want to cancel is on bottom, and what you want is on top. Okay. In this situation, we have copper plus silver nitrate, which is AgNO3, yields copper or silver Ag plus copper 2 nitrate. So that's CuNO3 2. So I'm going to need to put a 2 here and a 2 there. Okay, and we're doing moles of silver from moles of silver nitrate. So 3.65 moles of silver nitrate. And we want to know how many moles of silver we're going to get from this. So I just do the same thing that I had above. I plug it in, my given, 3.65 moles of Ag. Oh, this is not enough room. Sorry. Let's try this again. AgNO3 is so long. 3.65 moles of AgNO3. And remember, we want to cancel the units. So these are going to loop down here. We've got moles of AgNO3 and moles of Ag on top, because that's what we want. And so we look at the coefficients on the balanced chemical equation, because that's where those numbers come from, 2 and 2. 2 moles of AgNO3, 2 moles of Ag. So it actually comes out to be the same. We end up with 3.65 moles of silver, which is kind of easy. But that's okay. Some are easy, some aren't. Another thing, the template for this one that actually we've drawn a few times is saying if we have the given in moles of A, and so we have moles of A down here and moles of B down here, it's important to remember that the numbers right here, the number here, and the number here are the coefficients from the balanced equation. All right. Okay. So that's essential skill number 2. All right. Okay, so now we've got Sabrina, you put in, and Diana, both of you put in questions. So let's start with Sabrina's first because it was at top, I saw it. So number 10, B, and C on the study guide, please. So, where is that? This one? There we go. Okay, I will pick that one, 10, B, and C on the study guide. All right, let's screen share to the study guide. And we're gonna go to 10, B, and C. Oh, this is a fun one. Oh, you guys are killing me. Okay, so let me, I think it's a little bit too big. Okay. So I'm gonna have to do A, of course, in order to adequately do this one. Oops. So let's see, let's share the bamboo paper. And let's go to the next page. And we'll come back to, essential skill number 3 later. So this is study guide number 10. Let's just call it number 10. So A, you had to write the reaction. It says that the CO2 is exhaled by the crew. So we know that one of our reactants is CO2. It's removed from the air by reaction within canisters of lithium hydroxide. So we know that, I'm gonna do it up here, lithium is a 1 plus and a hydroxide is a 1 minus. So when we do swap and drop, it's just LiOH. So plus LiOH, okay? Now, when you do that, the products of the reaction are water, which is just plain H2O, easy enough, and Li2CO3, okay? So just to go through and double check everything, because we have to balance it, here's 1C, here's 1C. Let's get the oxygens right now. That looks kind of complicated. Let's go to the lithiums. Lithium here, oh, there's a 2 on that. So let's give a 2 in front of that. So we've got 2 lithium, 2 lithium. Now let's look at the hydrogens. So the hydrogens are pretty easy. There's 2 hydrogens, and there are 2 hydrogens. This is good. Okay, now we're left with oxygens. Here is 2 oxygens plus 2 oxygens, the 2 up front. That makes 4 oxygens in the reactants. And this is 1 oxygen here and 3 oxygens there. So that makes 4 oxygen. So it's balanced. All we had to do was this 2. That's nice. Okay, and I want to switch to B. I'm sorry, blue. On average, each astronaut exhales about 20.0 moles of CO2 daily. How many moles of water will be produced when this amount reacts with LiOH? Well, this is a mole-to-mole bridge. And if we remember, the template are given moles of A, and then we have moles of B down, or I'm sorry, not moles of B, moles of A on the bottom, moles of A down here, because that's what we want to cancel, right? We want to cancel that. And moles of B, because that's what we're going to. And the A is equal to CO2, and the B is equal to moles of water, H2O. So, set up our bridge again. A is CO2, and we had 20.0 moles of CO2. And so again, this needs to go down here. So we have moles of CO2 on the bottom to cancel out, and we want moles of H2O on top, okay? And then these numbers, right? We said this before. Oops. The number right here and the number right here, balanced equation coefficients, okay? So what are the numbers from the balanced equation? We look up here, H2O has a 1. We look at the CO2, it also has a 1. So the answer is, because the moles of CO2 cancel out, you're left with 20.0 moles of H2O. All right, and then C, how many grams of water are produced? Well, again, it's a one-step bridge, right? So, which is right here, you're given, this is essential skill number 2. So like, actually, let me do this. This right here, this is essential skill number 2. And this right here is essential skill number 1, okay? And what we have is given in moles in the same substance. So the moles have to go down here. And then we're converting to grams, and this is H2O and H2O. We know this is going to be 1 mole, and then this is going to be 18.02 grams, because this is the molar mass, right? So I'm going to write a little bit neater over here. And so we had 20.0 moles of H2O, with 1 mole of H2O, and 18.02 grams of H2O. And let's erase this because I'm going to write the answer right down there. That is equal to, I mean, I've already seen the answer, but 20 times 18.02, and I get 360.4. There's only 3 sig figs, so it's just 360 grams of H2O. So you all were overthinking it. It looks complicated because there's a ton of words. It's not too bad though. Good, all right, that one's done. All right, let's go on to Diana's. Could we please go over number 11 of the study guide? How nice. I feel like we're about to do the entire study guide. All right, so let's look at that. We're looking at number 11. Oops, no, that's not the study guide. That is my bamboo paper. Okay, there we go. Number 11. Ethanol, C2H5OH, is considered a clean fuel because it burns in oxygen to produce carbon dioxide and water with few trace pollutants. Write the reaction, and then you're going to do a 95 grams of water. How many grams of ethanol? So you're just going to go back, and there's just an H left off here, no big deal. So let's see. We can do this. No problema. All right, so let's do the bamboo paper. Okay. This is number 11. And A, we have to write the reaction and then balance it. So ethanol, they give you the formula for that. C2H5OH. So it's like 6 H's. That's all good. It burns in oxygen. This is combustion, so we have plus O2. yields, and then produce carbon dioxide and water. CO2 plus H2O. Well, let's check it out. All right, 2 carbons. So let's, and I'll do this in orange. So that's 2 carbons there. 6 H's, so I put a 3 there. Okay, so, and then we have 4 oxygens plus 3 makes 7. And we have 2 and 1. What happens if 4 and 3 is 7? What if I put a 3 right here? Let's see, let's double check this. 2 carbons and 2 carbons. 6 hydrogens and 6 hydrogens. 3 times 2 is 6 plus 1 is 7. 2 times 2 is 4 plus 3 is 7. And so it's balanced. Okay. So it's balanced with those coefficients. That was A. Okay. B. We have 95 grams of water. So we're gonna, and we're trying to find how many grams of ethanol. So it's the full bridge. Okay. And just to go through the template, you're given grams of A, and on the bottom, the molar mass in grams of A, because grams of A has to cancel out. And it's 1 mole of A on top, because the first step is converting to moles of A. And then you have moles of A on bottom, because again, this needs to cancel out, and you're converting at this point to moles of B, because that's the mole ratio. And on the bottom down here, you have moles of B again, because this right here needs to get canceled out. And you have, and that's a 1 mole. And then you have the molar mass in grams of B, because that's how you're converting it. And the numbers right here, number right there, come from the balanced equation, coefficients of the balanced equation. Okay, so let's write it out. Let's do this thing. Okay, so our given is 95.0 grams of water, H2O. And so down here we have to have grams of water, grams of H2O, because of course this needs to be the same to cancel, and moles of H2O on top. And we know that one's going to be 1. And the molar mass is 18.02. Okay, next we're going to put moles of H2O on the bottom down there. And we're converting it to moles of ethanol, right? C2H5OH. And so looking at the balanced equation, we have 3 moles of H2O and 1 mole of ethanol. And then the bottom down here will be 1 mole of C2H5OH. And that is going to be the mass. Let's look at it. So we have 2 carbons, so that's 12.01 times 2 plus 6 hydrogens, 6 times 1.01 plus 1 oxygen. Oh, that's all. 16. Okay, so I got a 46.08. 46.08 grams of C2H5OH. Running out of room. Okay, so then I'm going to multiply across the top. And so 95 times 46.08. And then I'm going to divide that by, we've got 18.02 equals. And we're going to divide that by 3. And I get 80.9766. Let's see, equals 80.97669, et cetera, et cetera. There's 3 sig figs. So 1, 2, 3 cuts off here. Very interesting. So that means it would probably be, that means this is around that, but that's going to round, the 7 rounds the 9, the 9 rounds the 0. So really what you end up with is like 81.0 grams of C2H5OH. So probably the toughest thing about this problem was the rounding. But again, a whole bunch of words, stuff you guys know how to do. You are definitely smart enough to do this. Don't let it trick you. You are more than capable. I believe in you. I won't sing. Okay, so that takes care of that question. So that's number 11. Excellent. Done. All right, Ashley Wilhelm. Can we go for number 9 on the study guide? We're covering the entire back page, aren't we? You guys are too funny. Okay, numero 9. So let's open that one up. Practice. All right. Number 9, write the products for this double replacement reaction. Okay, I'll give you that one's hard because you guys have probably forgotten, which this would be excellent review because you guys have such a hard time with review questions. And it's not just you in particular, it's all students. It's trying to figure out a way to loop it back in so you guys will keep after it, but definitely don't feel like you're by yourself on this one. So you write the products and you balance it, and then it looks like you do a limiting reactant. If 15 grams of zinc hydroxide react with 14.6 grams of potassium phosphate. So it gives you 2 of them, and you've got to do both of those bridges and find the least. So let's get cracking here. Go to the bamboo paper. Bamboo. All right. So this is number 9. And A. So we had K3PO4. Doesn't really matter if it's aqueous, but we'll write aqueous, plus ZnOH2. Aqueous. Okay, yields. All right, so what's going to happen is, what do we make this orange? The K, which is the cation here, and the zinc, which is the cation there, need to switch places. Okay, so we're going to have a zinc and a PO4, and we're going to have a K and an OH. Okay, so that's the first thing. You figure that out. Okay, I know that these are going to match up. And when you have 3 capital letters like this, right here, this indicates that there's a polyatomic ion. Like over here, it just so happens there's parentheses to help you out with that. But that's what the 3 capital letters look like. So I really like to put my polyatomic ions inside parentheses. Remember, they're untouched. You cannot do anything to polyatomic ions. Right? They have their charge outside the parentheses. Don't mess with it. So then you go look all of these up. And you look up zinc and you're like, I have no idea, it's a transition metal. Well, there's a rule for that, but let's just skip the rule for right now. PO4, you look at the back of the periodic table, you find out that it's 3 minus. You look up K on the periodic table, it's a K plus, and hydroxide is a 1 minus, okay? Now, what you could also have done is a reverse swap and drop on these. If you were not sure, you do reverse swap and drop. And the 1 from the zinc goes up to the hydroxide, which is true because that's a 1 minus, and the 2 would then go up to the zinc. Okay, and that means the zinc would be a 2 plus. You could also remember that zinc is always 2. That's a rule. Okay, so when we do swap and drop with these, the 2 swaps down to the PO4 and the 3 swaps down to the zinc. So you're gonna end up with zinc 3, PO4 2 plus. And on this one, it's just 1 and 1, so it's KOH. All right, so let's write out the whole equation as we should. And we have K3PO4, which we can put parentheses, at least that's the way I prefer it, plus zinc, O in parentheses, OH2, goes to zinc 3, PO4 2, plus KOH. All right, and let's go ahead and use red because I already used orange, and let's balance this. We've got 3 K, so let's put a 3 right there. And there's 1 PO4, but there's 2 PO4s over here. Ooh, we're gonna have to put a 2 in front of that to balance out those PO4s. And of course that messes up our Ks. We have 6 Ks now, and so I'm gonna go ahead and erase, oops, no, there it is. I'm gonna go ahead and erase that and put a new number there. That's got to be a 6. Okay, so that was pretty tricky, but that's okay. That's how we balance. And so that's the Ks are balanced and the PO4s are balanced. Let's go to the zincs. There was a 3 after that zinc, so that means we're gonna have to make this a 3. And that gives us 6 OHs, which is fine because that's 6 OHs. And we are now balanced. 2, 3, we leave this alone, and that's a 1. There's a 6 over there. So now let's go ahead and solve B. So that was A, now let's do B. We have to do I already said there's 2 bridges because we have 15 grams of zinc hydroxide and 14.6 grams of potassium phosphate. 2 masses, limiting reactant. Okay? So let's do both bridges. And let's give ourselves lots of room because these seem really long. Okay. So 15 grams of zinc hydroxide, ZnOH2. Okay, grams of zinc hydroxide have to go down here, and so that will look like grams of zinc hydroxide, and we're converting it to 1 mole of oops, didn't mean to do that. Zinc hydroxide, and we're following the template that we had before. And actually, this is just like essential skill number 3. I could almost reference this later because you're building that same bridge. So let's go ahead and add up zinc hydroxide and get its molar mass. Zn 65.39, and again, I don't know. That doesn't sound right to me, but it might be. Plus hydroxide, which is 2 O's and 2 H's. So that's 32 plus the H's, 2.02. And I get 99.41. Like I said, it doesn't feel quite right. Like I think it's different than our numbers for some reason, but oops, and it doesn't belong up there. That is for sure. 99.41. Okay. All right. So I drop that down. Okay, so I've got moles of zinc hydroxide. So we're going to do moles of zinc hydroxide down here. And we're converting it to potassium hydroxide. So moles of, and I forgot to put, we're doing moles of potassium hydroxide, which is nice because that's a lot easier than the zinc phosphate, which is be a ton. Moles of KOH, basically. And the coefficient in front of the zinc hydroxide was a 3. And in front of the potassium hydroxide was a 6. And then finally, 1 mole of potassium hydroxide. And so we have 16 plus 1.01 plus potassium, which is 39.10. And we get 56.11. 56.11 grams of KOH. All right. So I'm going to add all that up, and we'll write the number over there. So 15 times 6 times 56.11 equals, divided by 99.41 equals, divided by 3 equals. And so for my answer on that one, I get 16.9. How many sig figs? Oh, look at that. It should only be 2 sig figs. 16.9 grams of KOH. Okay, let's do the second bridge. Okay. For this one, we had 14.6 grams of K3PO4. And we're going to have the grams of K3PO4 on bottom. I'm going to calculate that now so that you guys know what I'm doing. 30.97, which is the phosphate, plus 16 times 4, plus the 39.1 times 3. And I got 212.27. I hope this is going right. I'm trying to move quickly. 212.27 grams of K3PO4 to 1 mole of K3PO4. And if you remember, this is the grams right here have to be the grams over here. So grams of A, grams of A, molar mass in grams of A, right? Oops, there we go. 2 moles of A. And then down here, we have to do the moles of A, which in this case, mole K3PO4, to moles of B. We're trying to convert to KOH. And you will notice this is the cool thing about limiting reactant problems, okay? Use green for this. From here over, like this, it's exactly the same for both tables. So I can just copy that down. It makes it a ton easier. There were 6 moles of KOH, and there were 2 moles of the K3PO4. And that means that this is 56.11 grams of KOH and 1 mole of KOH on bottom. Okay, let's multiply them all together. We had 14.6 times 6 times 56.11 equals, divided by 212.27 equals, divided by 2. And I get from this right here equals 11.57 grams of KOH. So I look at that and I say, hey, check it out. I'll use my red again. This is the smaller number. And so the correct answer should be 11 point, well, the answer says 11.6. Technically though, not about, I'm sorry, I shouldn't have made it that simple. What it should have been based upon sig figs, the correct answer should have been 12 grams of KOH. There we go. And so that means that my limiting reactant is the K3PO4. So much fun. All right, I need to take a drink of water. All right, so that finishes number 9. Good deal. All right, another question. Can you go over question 5 in the study guide? Derek, okay. We're on the first page. I thought for sure we would continue with the back page. Good. All right. Given 0.11 moles of carbon dioxide, how many moles of water are needed to react to form sugar? All right, so they give you an equation that just so happens needs to be balanced. Okay, let me switch to a bamboo tablet. All right. Sorry, getting distracted for a second. Okay. All right, number 5. Let's switch to blue ink because I like it better. In case anybody was wondering where we're at, number 5. Okay. And given the equation, CO2 plus H2O yields C6H12O6 plus O2. Let's balance this. 6 carbons, give it to orange. 6 carbons. Excuse me, 12 hydrogens. If we put a 6 here, that gives us 12 hydrogens. And 6 plus 2, that's 8. 6 plus 12, that's 18. Okay, that won't work. 18 right there. 18 minus 6 gives us 12. So if we put a 6 right here, that's balanced. Let's double check. 6 carbons, 6 carbons. 12 hydrogens, 12 hydrogens. 6 times 2 is 12. 12 plus 6 is 18. 6 plus 12 is 18. So we're good. Yay, oops, yay for us. Okay, and the question is given, let's go back to our blue ink. Given 0.11, oh, that doesn't look very good. It's hard to tell what it is. Most of my writing is that way, I suppose. So 0.11 moles of CO2, it's converting it to moles of water. Moles of H2O. It says how many moles of water. So it's a mole-to-mole ratio. So you're given 0.11 moles of CO2. And this, of course, needs to go on the bottom down here because it needs to cancel. So moles of CO2. What we want, moles of H2O. And then the numbers are the coefficients. 6 in front of the H2O, 6 in front of the CO2. So those are going to cancel out, leaving you with 0.11 moles of CO2. The answer. Yay, us. Okay, good. So that answered that problem. Good, all right, we're right on track. All right, so let's do essential skill number 3 now. Okay. And, oh, I should have just stayed on the bamboo paper. I don't know why I got off of that, huh? And, okay. So I think I was doing those in green, or at least I was looking like this. Essential skill number 3, and that's a gram to gram bridge, okay? And so I've already done it a couple times. Let's just go over it again. Your given is right here in grams of A. And this right here has to cancel out, so it goes down here, grams of A. And that is converted to moles of A. So that means that this is the molar mass in grams of A, and that's 1 mole of A. And this has to be down here because it has to be canceled out. Moles of A on bottom. And you're converting to moles of B because eventually you have grams of A going to grams of B. So this is where you would convert that. And then finally, the moles of B comes down here so that it will cancel out, and grams of B on top. And this is the molar mass, and this is 1 mole. And then, of course, the numbers that would go right here are the coefficients from the balanced equation. Okay, so let's demonstrate on a problem. I have a mixed review, I believe, and we've got, so how many grams of iron 3 chloride are produced when 15.3 grams of iron react with excess chlorine gas? So I'm going to write the equation and then we can just solve it, but you guys can do this. You're so smart. Okay, let's do the bamboo paper. Okay. And go to blue ink because I love me some blue ink. All right, so we have when iron reacts with excess chlorine gas. So iron reacts with chlorine gas, Cl2, to produce iron 3 chloride. So Fe, so what you have is iron 3, Fe3 plus, and a Cl minus, oops, because it's a 1 minus. So it's FeCl3, which means you're going to put a 2 here to balance it to give you 6 chlorines. You're going to put a 3 here to get 6 chlorines. And then you have to put 2 for that for 2 irons. And we're given 15.3. Oh, you know what? I want to not do it like that. Let's open it up. Okay. So we have 15.3 grams of iron. And the molar mass, 55.85 grams of iron to 1 mole of iron. And then you have your coefficient, 2 moles of iron. And the, the B, what are we converting to? We're going to iron chloride. So it's Fe2 FeCl3, sorry about that. So that means you're going to get 2 moles of FeCl3, and you have 1 mole of FeCl3. And so to get the molar mass of that, 55.85 plus 35.45 times 3 gives us 162.2. 162.2 grams of FeCl3. And so if I multiply that all together, 15.3 times 2 times 162.2 equals, divided by 55.85 and divided by 2 equals, and my answer is 44.4. 0.4 grams of FeCl3. Yay! Okay. And that's how you do essential skill number 3. Rocking and rolling and whatnot. Okay, so Derek, your next question about percent error is in the, it's in when I did that limiting reactant in a problem That one was, oh, that was an earlier one. So why don't I do that? Why don't I combine those all together? So I'm going to select your question and say yes. I'm going to go over percent error next, and it's in the very next problem. And how do you find limiting reactant in a problem? We did that. How do you find percent error and percent yield? So let's go back to a problem that was limiting reactant. And in this case, it would be this right here, okay? This was number 9 on the backside. Now, the question is how do you get, like, because the questions that always follow limiting reactants are, well, then what's your percent yield and what's your percent error? All right, and so we're going to add a little bit in here, and we're going to say, let's use orange because that's kind of bright, but still shows up. This 12 grams of KOH, okay, this is your expected, okay? It's also called, in the notes, it's called the theoretical. It's like, what could you potentially get? What could you theoretically get? What do you expect to get from this? Well, we expect to get about 12 grams, okay? And you could say, well, this one had 3 sig figs. So you're welcome to use the 11.6. You say, oh, 11.6 grams. I suppose that's true, huh? It would just be, anyway, it doesn't matter. Not worth the argument, of KOH. And then we would have to, let me take you to another page. Let's remember that 11.6 grams of KOH. Okay, so our expected / theoretical equals 11.6 grams of KOH. Okay, and then they say, okay, but what happened? What did you do in the lab? Actually, in lab, we observed, like I'm using all the words, huh? Observed 11.2 grams of KOH, okay? So the actual or the observed, that is what happens in the lab, what you actually end up doing, okay? So if you're doing a percent yield, okay, the percent yield is the, we'll call it the actual over the theoretical, okay? You could also call it times 100, sorry, times 100%. It's, I don't know which way is easier for you, the observed divided by the expected times 100%, okay? So that means that it's equal to, in our case, the observed or the actual was 11.2, and the expected or the theoretical was 11.6 times 100% equals. So 11.2 divided by 11.6 times 100. 3 sig figs gives me 96.6. 96.6% yield. Okay, great. But you know, how far off were you from getting it right? Let's say they didn't ask the percent yield. Let's say they asked, rather, the question just came right out and said you got 11.2, but what's the percent error of that? Well, the way that you would solve that is to say, okay, well, it's the observed minus the expected, all divided by the expected. And that's an absolute value. Okay, so how far, observed minus expected is like how far are you from the original? And then to get a percentage, you've got to divide it by the total times 100, right? Observed minus expected, that's subtracting it from the total. How far off are you? Okay, and that's of course times 100%. So that was equal to, so the observed 11.2 minus 11.6 divided by 11.6 absolute value times 100%. And we end up with, let's see, 11.2 minus 11.6, enter, divided by 11.6, enter, times 100, and we get 3.4, if we round it, 3.45. 3.45% error, okay? Should label that really a lot more closely. Percent air right here. Okay, and that's what this is. So percent air down here, percent yield up there. And of course, you will have those questions on the test. Now, not exactly those numbers, but it's the same idea. So you have to look for it and know and understand what numbers are being provided to you. Okay, so that completes that. Finally, what happened in that magnesium oxide lab? So this can be frustrating, trying to figure out what happened and what's going to be expected of you. So let's do the lab. Let's talk about it. I would say that you need to conceptually understand what's happening and why. Okay. So what we did is, I'm going to draw pictures because that's what I'm really not good at. So I don't know why I'll continue doing it. This right here, of course, is your magnesium ribbon. Okay. And you have a crucible. Too bad I can't really draw, huh? Okay. And so the question is, well, you know, what are we doing and why are we doing it? All right. So we've got flame here. I'm spending way too much time drawing this, so we're gonna quit doing that. What color? Oh, that's right. It was like this. Oh, no, that's not what I wanted. Okay. Okay, so what we did is we were trying to produce magnesium oxide. And the way we would do that is it's got to be Mg plus oxygen yields MgO. Well, hopefully you all are sitting out there going, hey, wait, Mr. Warner, oxygen? That's diatomic. That's one of the Brinkelhoff elements. So good job, everybody. I'm glad you caught me on that. So Mg plus O2 yields MgO. And then you balance it and you get 2 MgOs, so you can get 2 O's. And you got to put the 2 over here so that the Mg's will balance out. And this right here is a synthesis reaction because 2 things are becoming 1. Okay, so 2 things become 1, synthesis. All right, so now you are taking your ribbon that you've masked. You mask it first, and then you mask crucible so that you can subtract out that mass later. And then you move that over to the heat, okay? All right, and for a while there, you had the lid on. Okay, you had a lid on there for a while. And then after a while, you took the lid off. And that allowed oxygen to come in. You want that oxygen in there because you want all of the magnesium ribbon to react with the O2. You want as much of the ribbon as possible to react. That's why you didn't totally put it in a ball, like scrunch it all up, because you want some of that magnesium to be exposed to the air so that when it heats up, you know, it'll definitely react with the oxygen. So we took the lid off after a certain amount of time and let it hit the air. Now we left the lid on for a while because, well, it smokes. We don't want to lose the smoke because that's losing mass. And we also, it's really bright. We don't want to hurt your eyes. Okay, so then it cools and you mask it again. So mass at end for MgO. And you had to subtract out the massive crucible. Okay, so mass out the crucible, or subtract out the mass of the crucible at the end. And through all this, you guys learned from our discussions in class that this is endothermic. You had to add heat to this, right? You had to add all that flaming heat in there, so it's endothermic. And then some key thing is that you had the mass. Actually, let's do this. Let's make this orange. So the mass of the magnesium ribbon, okay, while you're waiting, you did a bridge, right? Grams of magnesium, 2 grams of magnesium oxide. And that was the 4-step. That's the big bridge. And this right here, I'm gonna do this right here, this right there, is your expected. Because that was your theoretical. This was the one that you could, if you did everything correctly, that's what you should get. All right. Now, but this magnesium oxide right here, you masked at the end. This magnesium oxide right here, well, that's what you actually did. Not theoretically, but what you actually did, or what you observed during the lab. Okay. So that was the piece of that. So if you're given the mass of the magnesium, if you're given the, I'm going to put a star by this, you're given the mass of the magnesium on the test, you better make the bridge to get the magnesium oxide, because you got to know how much to expect, okay? And then you're probably going to be given the mass of the crucible and the mass of the magnesium oxide at the end. So you're going to have to subtract out that mass of that crucible. So let's do this. Let's call this step 1. Step 1 is taking the magnesium and finding out how much magnesium oxide there is. I'm sorry, taking the mass of magnesium and determining how much magnesium oxide is expected. That's step 1. Okay? Determine expected. Okay? Step 2 is subtract out the mass of crucible to get mass of MgO. And that's going to give you your observed. Determine observed. Okay? Now, again, I got to tell you, I don't know what's on the free response, whatever. This is my best guess if I was looking at this. Ms. DeMaria wrote this up. 3, you should be doing percent yield and percent error from what you did in the first 2. You got your expected, you got your observed, find the percent yield and percent error, just like that. Shazam, okay? And I don't know if we wrote, in any questions that are like, well, why did this happen? Or what type of reaction is this? Or I don't know if there's anything like that, or if it's just numbers. So I would say, of course, just be prepared for anything. But that's the crux of it. That's the whole thing. That's what we did in class when we went over it. Things that you needed to include. I think probably people lost points on not doing percent error, or they lost points on. They lost points on. The words are escaping me. They lost points on not doing percent error, or they lost points on not including the why or something in their procedure. So, but I think that you guys can do this. You guys absolutely, we've covered it. You understand. Or I say that. I'm not saying you understand. I'm saying that you've been exposed to enough that I hope you do. Please come ask me questions if you don't, though. All right. There were no other questions typed up after in the last 10 minutes or so. So I'm assuming that you all are finished asking questions. It's 9 o'clock, which is good. That's an hour. I feel good about this review session. I feel like it covers the core things. If I have other worksheets, I have other problems. If you guys want to see those, or you guys want to do those, come in and see me in the morning, and I'll be happy to run you through a couple of those. Don't forget to do review. Please do review. I cannot emphasize that enough. Go back, look at your notes, go back and do the review quizzes from past units. Go sciencegeek.net. I mean, those are the things that are gonna really help you. And I'm just gonna write them on the next page. I don't know if you're gonna do it. So, oops. Wait, yeah, no, 10, okay. Review, notes, so past notes, review quizzes, and sciencegeek.net. If you do that, I don't know. I try to emphasize these things to you guys, and I think some people do it, some people don't. I just hate for you guys to miss those points. Okay, enough for now. Good night, you guys. Also get a good night's rest. Sleep is important, and I will see you all tomorrow or the next day. All right, bye.